Hey, Algebra 2 kids, this is Dr. Callahan for week 4 Thursday. This is your warm-up, so pause the video and answer the following questions. Happy Thursday. All right, so week 4 Thursday. There are several things you're going to need for this class, one of which is, let's go over the warm-up first. So for questions number 1, you can go ahead and combine your like terms when you're adding your polynomial one of 2 ways. The first way is a vertical way, and so you just stack them on top of each other. X squared with the x squares, x's with the x's, numbers with the numbers, and then you just add them up and down. 4 minus 3 is going to give you a 1. 3 minus 6 is a negative 3. Negative 4 and negative 3, you combine them together, it gives you a negative 7. So that's your answer for question number 1. And make sure you guys are completing your warm-up log because it is due on week 9 Friday. So this is week 4 Thursday. So you guys have about 5 weeks left. Now, number 2, if you're to combine like terms, this one is a minus. So if it's a minus, remember, it has to be opposite. So everything in the second parenthesis is opposite. So negative 2y cubed minus y, negative 2y to the 4th, negative 11. And so you just go ahead, or positive 11, and then you just combine them. So group them together, the 4s, or the 4th power, the 4th power, cubes by itself, just the letter y, just the numbers. And then when you combine them all together, this is what you should have. Okay, let's move on to the next part. So remember, every day or every week, you guys have your math excels, and so this is week 4, so you should be focusing on your week 4 math excels. I don't assign you guys any homework that's on paper. Everything is going to be on math excel. So every week, you guys get 1 math excel. And it's usually like 10 to 15 problems. It doesn't go over 15 problems. And then also every week, you guys get 1 of your assessments on Math Excel as well. And normally it's just about 5 problems. Okay, so make sure you guys are doing that. It is due every Sunday by 11 p.m. And then I update your grade the following Wednesday with those assignments. Now, if you're like, what if I didn't do week 1, 2, and 3s? I usually reopen them, and you could still turn those in for the ones that's already due. But then there is a penalty because about 50% of you guys turn it in on time, and the penalty is 10 to 40%. Depending on how late it is. Like if it's 15 weeks late, then yes, it's going to be a 40% penalty. But if it's like only a week, 1 or 2 weeks late, it's usually a 10% penalty. So just keep that in mind. How do you go ahead and raise your grade? Because your grade are updated. It's on Infinite Campus and also put it on MS Teams. You need to attend regularly. Make sure you guys do the warm-up, exit ticket, and the guided notes. And when I have you guys turn things in, like your guided note packets, make sure you turn those in. Your Math Excel and your quizzes is really important because there is that late penalty. And then if you need any tutoring, remember I have the tutoring schedule given to you guys on your QR sheet, and it's usually just after school. Okay, so since last week, you guys have already turned in your packets. So you should have a brand new packet for unit topic number 4. If you have not turned that in yet, you want to do so as soon as possible because I will be grading that this weekend. And yeah, that's basically it. Okay, so today we're going to be right there. We're going to talk about inverse variation and reciprocal functions. And then these are the objective. Inverse direct variation functions, day 2. It's going to be a little bit different than day 1 in that, I'm going to change this a little bit, that you're going to have real life application problems today. So it'll be a little bit different than yesterday's stuff. So day 2, today we're going to do a Desmos activity. It's going to be 8 questions, and you just type your responses on Desmos. So this is what you need. You need to have a cell phone or an iPad, a TI-84 calculator, and then also the handout from me. So come on up. My iPads are right here. The TIs are right below this. And then I have the handout right here. So make sure you guys grab it for yourself. So first things first, let's go ahead and start off on this chart. Make sure you guys put down your name and then today's date. We're going to go ahead and recognize the differences between direct variation and indirect variation. And we're going to fill out this chart to kind of help you guys out a little bit. So first things first. On the left side is direct variation, an equation in the form of y is equal to kx, where k cannot equal 0. And as, I guess I should go ahead and compare it left and right. Yeah, let's do that. So on the right side is your inverse. So it's an equation in the form of y equals k divided by x. And again, k cannot equal 0. So basically with the direct variation, as x increases, y also increases. So if one goes up, one goes up, or if x decrease, then y decrease. Okay, so if one goes up, the other one goes up. If the other one goes down, the second one goes down. What's different about this one is that it's going to be opposite. So this one here is same direction. This one is opposite direction. And by opposite, I mean that if one as x increase, y decrease, and vice versa, as x decrease, y increase. All right, so the graph of the direct variation equation is continuous. For all values of x and passes through the origin, and the origin is at 0, 0. On the other hand, for inverse, the graph of the inverse variation is not continuous. And for all x values, it does not have a y-intercept. So for example, what does a graph look like? Direct variation, it's going to be y equals 3x. And so when I graph it, I just simply start at 0, 0. Because remember your b is at 0. And then you just simply go up 3 over 1. So 1, 2, 3 over 1. Up 2, 3 over 1. Up 2, 3 over 1. And then you just draw your line. On the opposite side of that is inverse variation. So that one is like y is equal to 5 over x. So I don't know about you, but I can't just draw that like just by looking at it. So I don't know what it looks like. And so let's go ahead and try to graph this then. So grab your calculator. There's mine. I'm going to go to y equals 5 divided by x, and then hit graph. And you want to copy that down so you have a picture of what it looks like. So if I go back to here, I'll just draw my picture. It kind of looks like this and like this. And notice it doesn't touch the origin. It's not going anywhere near 0, 0. So next I'm gonna have you guys do is with your cell phones or your iPads, I want you guys to Google examples, like real life examples of direct variation and indirect variation. And I want you guys to come up with like at least 2 on your own. But before I release you guys to do that, I want to make sure that you guys understand what it is. So I'm going to come up with one with you guys. Okay, so my example of direct variation, you got to think about it. If one go up, the other one go up. Or if one goes down, the other one also goes down. I would say like if you had a job, right? I would say a direct variation is hours worked and your paycheck. Because I would assume that if you work more hours, you get more money, right? It shouldn't go the other way. It's not like the more hours I worked, I get less money, because that wouldn't make any sense. Then I just wouldn't work. So that's my example. So I want you guys to come up with 2 more, and you can Google it if you want, okay? On the other hand is going to be your inverse variation. So this one is when one goes up, the other one goes down. So I don't know about you guys. I personally don't like pizza because my kids, I have 4 of them. They love pizza. All they want to eat is pizza. And I'm like, it is so bad for you. Like, so if I never eat pizza again in my entire life, I will be okay with that. If you're like, you'll never eat seafood again, I would be like, okay, well, that's going to be a little bit difficult for me to let go. I never have seafood ever again. But pizza, I can, never eat pizza again, or hot dogs. I'll be okay with that. I know you guys might disagree with me, but that's fine. And my kids will probably like lose their shit if I actually tell them that we're never eating pizza again. So an example of that is the number of people eating the pizza and the number of pizza that's available or left. And that makes sense because if you have not too many people eating the pizza, then you have a lot of pizza left over, right? That makes sense. It's opposite, okay? So now that I came up with this, I want you guys to come up with 2 more. So use your cell phone, use your iPad, give it a try and see what are some other examples you can find with that. All right, you guys, so let's go ahead and think about some other examples, okay? Another one that I thought of, and I want to move this up just a little bit. There we go. Let's see. It could be, if everybody had like an iPhone, think about your iTunes account, okay? The number of songs purchased and how much it's going to cost. That's another one. And that makes sense because if you purchase more songs, which I don't even know, do people even purchase songs on iTunes anymore? I thought people just use Spotify or Pandora. Then it will be more money charged to you, okay? Or another one is, most of you guys probably are out of age where you can drive. So let's say if you're going to take a trip, okay, distance, trip, and then also the time it takes to go to the location. So let's say, for example, if you're just going down to 7-Eleven, which is not going to be that long, it's probably going to be like maybe 6 miles. Okay, so it's not a long trip. Time, not a very long time, maybe like, I don't know, 5 minutes or so. Okay, so one goes down, the other one goes down. On the other hand, inverse, let's see, we're in winter, so let's stick with a winter theme, okay? And so we'll take the time it takes snow to melt and the temperature. okay? If you think about it, if it is like really cold, then the amount of time it would take for snow to melt goes up. It's going to take a long time, right? Whereas on the other hand, if it's going to be very hot, as in like the temperature goes up, then it's going to melt very fast. So the time it takes to melt is very small. Okay, so those are some of my examples. You should have came up with some on your own as well. But now you guys kind of like get how this works, right? All right, so then let's go ahead and go on to the next part. So I'm gonna have you guys turn over to the next part, which is the back of this. And let's go over some examples. Let's first fill out this little chart right here, okay? So this is your chart, and this is description of the quantity, how it varies, okay? And this right here will just be the formula. All right, so looking at this right here, the first formula is going to be y is equal to k to the x. And the description of that for direct variation is that as both quantities increase together and they decrease together. On the other hand, with indirect, notice the x is on the very bottom. Description of that is going to be as one quantities increase, the other quantity decrease. And that's all you need to write down. We're not going to talk about joint, and you don't need to copy that part down. And now I'm going to give you guys some real life examples where we actually can apply this. All right, let's take a look at example 1. Go ahead and read that one. Okay, so when an object such as a car accelerates twice the distance. Now remember with this one, distance always equals s times time. So it's distance equals speed times time, okay? It says twice the distance d. It travels varies directly, and if it varies directly, it's y equals k times x with the square of time, so t squared. One car accelerates for 4 minutes, and it travels 1,440 miles. What's the distance? Okay, so when I set this up, the way I kind of think about this is when it says when the car is accelerating, that's a speed, okay? Twice the distance, so I put 2d is equal to, it travels varies directly, so it's going to be speed times time with a square of time, so t squared. One car accelerates for 4 minutes and travels for 1,440 feet. Writing equation, relating distance traveled to time lapse, then graph the equation. So there's my equation right there, and I know that the distance I travel is 2d, which is 1440, equals s times t squared, so that's 4 squared. So then if I multiply this out, that will just give me 2,880 equals 4 or 16 s. And then if I go ahead and solve for s, which is just going to be 2,880 divided by 16. That will give me 180. So my speed is 180. So then for B, it says use the equation to determine the distance traveled by the car in 8 minutes. So then I have 2d equals s times t squared. If my speed that I just found is 180, I'm going to put 180 right there for speed, right there. My t here is 8, so I'm traveling in 8 minutes, so times it by 8 squared. 2d. Well, let's go ahead and figure that out. What is 180 times 64 divided by 2? So then with my calculator, which you guys have as well, 180 times 64 divided by 2, 5,760 miles. And that's how you work this problem. Okay, so let's take a look at example 2. So the stretch of a loaded spring varies directly. So directly just means y equals k times x, okay? So the stretch of a loaded spring, so we'll just put stretch. So let's just say that's y, is equal to k times as a load supports. So I'm going to put support, which is x. A load of k kilogram stretch, so that's 8. A spring of 9.6 centimeters. Find the constant variation and the equation of the direct variation. Equals, let's say, k times 9.6. So then if I were to find k, so k equals, I will have to divide that 8 divided by 9.6. So then I'm going to go over to my calculator. 8 divided by 9.6, which is going to be a 0.83. So k equals 0.83. So then I'll just have y is equal to k, which is 0.83 x. And that's my equation, okay? Y is still the stretch, x is still the support. So then the question here says, what load would stretch the spring 6 centimeters? So then if this is my equation, I'm going to use this, okay? So y is your stretch, right? I'm just going to kind of keep in mind which one's which. So if y is stretch and the stretch is 6, I'm going to put 6 is equal to 0.83x. What is x again? Your x is the support of the load. So x is the support of the load. So then my goal here is to solve for x. So let's go ahead and divide it by 0.83 on both sides. So once again, you're going to go back to your calculator. And we're going to go ahead and divide 6 divided by 0.83. So here's 6 divided by 0.83. And what is the load that you have? It's 7.23. So x equals 7.23 load. And the load is going to be in the unit of kilograms. And that is your answer. Okay, so now that we talked about direct variation, let's now talk about indirect variation, okay, and see how is that going to change. So we're going to go on to example 3. If you take a look at example 3, go ahead and read that one. When I read this, I see the word inverse, and immediately I'm like, okay, let's write down the equation, which is y equals k divided by x. And then from there, I want to ask myself, okay, what does y represent and what does x represent? And that's going to be aligned to the question that you guys have. So the total time required to travel a given distance, so distance is d, is inversely proportional to the speed. So S for speed of travel. If a trip can be made in 3.6 hours, so T equals 3.6 hours at a speed of 70 kilometers per hour. So they must be in Europe because we don't use kilometers here, we use meters. How long would it take to make the same trip at 90? Yeah, go ahead. So the question here is how long. So my goal here is to figure out what T is. All right, so let's start labeling, okay? Y is going to give you the distance. It's equal to inversely proportional to the speed of travel. So remember, your distance equals speed times time, like that. So then if it's going to be inverse, then distance will equal to S divided by time. Okay, so just have to flip around a little bit. So if distance equals S divided by time, let's use the first information they give us. If a trip can be made in 3.6 hours, so I'm going to replace that T with 3.6 at a speed of 70 kilometers. So that's going to be 70. Now I'm going to go ahead and find the distance, okay? So then let's go ahead and divide this. So 70 divided by 3.6 is my distance. And what is that going to be? I'm going to bring back my calculator. 70 divided by 3.6. That distance is 19.44 kilometers. 19.44 kilometers, okay? Now I'm going to rewrite my equation. So I'm going to have 19.44 equals S over T. Okay, that's my new equation now. Now from here, I'm going to read the second part of the question, which is how long, so I want to find T, that's what I'm trying to find, it will take to make the same trip at the speed of 90. Okay, so then with that information, I'm going to go 19.44 equals S over, and I know S is 90, T. And my goal here is to solve for T. So T is on the bottom, and going back to algebra 1, remember you're going to put a 1 underneath that, and then you're just going to do crisscross applesauce. You're going to cross multiply it. So When you do that, it's 19.44t equals 90, because you're going to cross multiply them, right? And then how do you get rid of the 19.44? You just divide it. So what is 90 divided by 19.44? 90 divided by, was it 9.44 or 19.44? I forgot. Oh, 19.44. And what is your time? 4.63. What is it? Hours. There we go. That's the unit. Ta-da! And that's your answer. I know it's a little weird. Okay, I get that. But, you know, more practice, you guys will get better with this. All right, I'm going to stop right here. I'm going to have you guys practice with Desmos. So with your cell phones, we're going to go on to Desmos, and I'm going to give you guys a code. So make sure you have a cell phone or an iPad. If you guys just type into go or desmos.com, it's DESMOS. And it doesn't look like it's giving me a code. So let me see if I can use a QR code instead. So maybe that'll just take you guys directly to that. So what is happening here? What's going on? Okay, so if you guys can take your cell phones and then just use this code for Desmos, let me know if it takes you guys to that. So use that camera. Yep. And does it take you guys to the page? And for my kiddos, that's going to be online. I actually have a link for you guys as well that you'll be able to use. And once you get in there, you guys, you're welcome to just go ahead and get started with the 8 questions. It's going to ask you to type in your name. It does ask you for an account, but you can log in using your Google account, or you can just sign up for it. It's just asking for a username. And you want to do that because we actually use Desmos a lot here in this class. So it's kind of important that you guys have an account with them. So I just went ahead and signed in, and then it's going to tell me like, welcome Dr. Natalia Callahan. And then you just like click on start activity. And then it just simply asks you 8 questions about the Lego prices. Okay, so you guys can go ahead and get started with that. So for my little friends on Zoom, so this is kind of what it looks like, and 8 questions, and then you should be good to go. When you guys are done with this, keep in mind that your exit ticket is going to be looking like this. So let me pull that up for you guys. And today is week 4 Thursday. So this is your exit ticket at home. And also you can use the form right here if you want to type it in. Other than that, I hope you guys have a good day. Take care.